So in this case, I want us to consider another typical example if you are to work with your Kirchhoff's laws. Remember, we can also apply this on a bridge network. So that is applying Kirchhoff's laws to a circuit with branches. Calculate the current in each branch of the circuit. So in each and every branch, take note, in each branch of the circuit, meaning to say, we are supposed to calculate the currents that are given first. The current 1, current 2, current 3. But what about this part? Because it's a branch, this one, BD. What about this one, CA? It's a branch also. What about DE? It's a branch also. And we are not given these currents. We are only given that this is I1, this is I2, this is I3. So what you're going to need is to determine or have expressions for these currents. That is the branch of BD, this of DE, and this of CE, because they are not given. If you are given, guys, there's no need for this. You just consider your loops. You're going to use this loop. You're going to use whatever loop that you are considering inside. But in this case, you cannot because of the currents that are not given. All right, so let us figure out. Calculating first, determining, and then after that, you're going to need also to calculate the voltage. You can see that one later on. But the first thing is that we need to calculate all the currents. So the first part that you do, just determine the other currents in that case, meaning to say, just fill in the diagram, the branches. Okay, just try to fill in everything that you are given, unless they have given you that. All right, so let's apply our Kirchhoff's current law at B. Okay, at this point B, what is happening? I1 is entering, I2 is leaving, and this current across this branch BD is leaving. Remember that the sum of currents entering, which is I1, must be equal to the sum of currents that are leaving, which is this I2, which is leaving, and the current across the branch of BD that we do not know in that case. Okay, gonna find it in terms of I1 and I2. So how can you find it in terms of I1 and I2? Simply take I2 to the other side. That's I1 minus I2 is the current across the branch of what? Of BD, this one. So you have to determine these currents. So the current across the branch of BD here is going to be written in terms of what? You write it in terms of what? What you are given on the diagram, I1, I2, or I3. So there it can be written in terms of I1 and I2. So that's the difference, the I1 minus I2. This is the current flowing in the branch of BD. All right, let's move on. If you're to notice here at C, at point C, there's a current that is flowing towards, which is I2. And there are currents that are flowing away, which is this current in the branch of CE and this current in the branch of CD. They are flowing away. Idea is still the same. The sum of currents that are flowing in at point C, what is flowing in? That is I2. Must be equal to those ones that are leaving, which is this one, in the branch of CE, plus this one that is leaving, which is I3. These are the currents that are leaving. The current in this branch of CE and the current of I3. So let's find this current in the branch of CE in terms of what you're given on the diagram. So means you're going to take I3 to the other side. That will be I2 minus I3, which is the current across the branch of what? of CE. So this branch of CE, the current that is flowing this direction here, which is this one presented there, is going to be given as I2 minus I3. So that's I2 minus I3. This is the current that we have here. This is the current flowing across the branch of CE. All right, like I said, we need to fill in. We are now left with this one across DE. Let's focus with the point D because there are currents that are there at point D, or you can focus with the point E. It's a choice. Okay, that one is a choice. All right, let me start with the point D. Let me show what I'm trying to say. If you check at point D, the currents that are flowing towards D, remember the sum of currents in to the D, we have got I1 minus I2 is flowing, this one, in. And I3 is flowing in to D. So if we add I3, we must find the current that is flowing away out of D, away, which is this one. So this is equal to the current IDA. This one, the current in the branch of DE. Currents flowing towards the junction, towards these ones. They're flowing, they're going to D. Must be equal to this one, away from D. So meaning to say this branch of DE, the current flowing is going to be given by this expression. So that is going to be I1 minus I2 plus I3. Okay, like I said, let's say we do not want to use the point D, okay? This is what we have. Let's say we want to focus with the point E, this one. Why the point E? Because if you check the currents that are now flowing, this is another way that we could have determined the same current, this one. This is another way. The currents flowing towards the point E will be the current across CD, the CE and DE. These are the ones flowing to in this part. We're talking of this current across CE, which is given as I2 minus I3. And this current in this branch of DE, which is the current of the branch of DE. These are the ones flowing towards the junction of E. This is where we have. They must be equal to the one flowing away from E. Which one is flowing away? We can see that the current flowing away from E is given as what? As I1. It is flowing away from E. So it must be equal to I1. So these are the sum of currents in. These are the sum of currents out. What is flowing in? What is flowing out? What is it that we want? As we want to find this one. So we can make it the subject. So that is IDE is going to be equal to what already? There is I1. I'm going to take I2 to the other side. It will be a negative. You take minus I3. Remember, it was a minus. So it will be a positive there. So as you can see, that's the same expression that we have for the current across the branch of DE. I1 minus I2 plus I3. So that is what you are going to have. That's another way that you could have determined this same current here. So you say this is I1 minus I2 plus I3. So this is it. So like I said, in a typical exam question, because of the issue of marks, this and that, they want to make sure that issue of marks also are properly distributed. They can fill in all these branches for you. They fill in all the currents, everything. They can even give you the loops to use. But in this case, you're not given. You have to fill in. Then you can consider now the loops of your choice. Remember, Kirchhoff's law. We are going to need the loops of our choice. All right. So in this case, it's your choice, guys. I'm going to start with this loop here, where we've got a voltage. The loop here, this one, I'm going to take it this side, this way. Okay. Let me just show you the way that I want, like this. To B, going to C, to E like this. This is the loop that I'm just considering. So I'm just going to present it like this, guys. You must understand what I'm trying to say. This is the loop that I'm talking about. All right. So in this case, taking loop 1, just going to call this loop 1, which is from A to the point B, back to C, to E, then from E to F, then back to the point A. This is the loop that we are talking about in terms of the given letters. All right. If we consider this loop, like I said before, concept is not going to change. Are we having the sum of the voltage drop equal to the sum of the given voltages, source voltages? Are they equal to the sum of the voltage drops? They must be equal. So we only have one voltage source, which is 30. So you're going to consider that 30 is equal to, as we can see, according to the flow of current. In this diagram, it is flowing from the positive. Remember, I talked about another indication of the flow of currents from the hands-on textbook, so that maybe if you're using hands-on, you'll see that your diagrams, they are not as you are used to from other textbooks. So you just have to get used to that. But if you're using the TVET series, I think that's the normal formality that we are, like, almost all of us understand. So this is how also the current is going to be taken in the loop that you're taking. So meaning to say I1 is going to be positive, but we do not have any resistance in this branch. So meaning to say there is nothing that is going to affect I1. It was supposed to be current times resistance. So we do not have the resistance. So it will be just 0 I1. So there's nothing to consider about I1. We do not have resistance. That is from A to B. So you move on because there's nothing there. Okay? From A to B. So you're going to move on from B to C. Are we moving in the same direction of our loop? Yes, the current is moving in the same way. So that'll be a positive. So that's 40 times I2. We are moving in the same direction of our loop. Okay? You move on from C to E. You are moving again. The current is moving in the same direction of our loop, the way that we've taken our loop. It is moving in the same. So it's a positive again. That's 40 times current, which is 40 times the given current, I2 minus I3. That's our current there. That's it. If we move on from E to F, that is the same branch that we had before here, where we just have current I1, but no resistance. So there's nothing left there. You can expand your brackets. Thus, you've got an equation there. So that's 30 is equal to, we're going to have, in this case, 40 I2, then expand the brackets there. That will be distributed by 40. That's 40 I2, 40 times I3, that will be 40 I3. As you can see there, we've got the like terms I2 and I2. So you can consider that. Add 40 plus 40, that was going to give us 80 I2 minus 40 I3. Okay, that's our equation. So you can consider this as equation 1. Way that you solve thereafter is your choice. So I formed an equation in that case, guys. So here, guys, we are worried about forming of the equations that we are going to solve thereafter. So, guys, I'm just going to list my equations here for the sake of our revisions. So the first one, just going to write it as 80 I2 minus 40 I3, which is equal to what? Which is equal to that. So this is what we had. Let's move on to another loop. Here we are done. We're going to consider another loop. So considering the loops, guys, it is up to you. If you want to maintain using the 30 volts supply, it is up to you. You can maintain that by using the loop A to B to C like this. You can move on. You can even move like this from C to D. You move on from D to E. You move on back like that. It's a loop. Guys, look, you've got a lot of things that you have to consider there. But if you do understand that, use it. You can take this loop like this. You can even decide to take it like this. From A, you can move on to B like this, to D, to E like this. You're back to A. Since you want to use the voltage, You can choose to work it like this from A to B, then like this from C. Okay, this one we took it. All right, this one we took it. All right, this one we took it. Maybe if you had to take it this way, like this. But this one we took it, guys. All right, you can take those ones. But if you want, you can also avoid that part. All right, you can even take the other way. Like you can even make like a Z concept. But guys, this is your own question in your hands. You can even avoid all that confusion of working with more resistors. How to avoid? Just take a loop of your choice. Guys, it must be a closed circuit. For us to consider this, we are working in a closed circuit. That is what we defined our Kirchhoffs. In a closed circuit. So this is closed. You can take it. This here is also closed. So I can just consider my loop like this, from B to D to E back to B like that. It's a loop. This one that I'm indicating here. It's a loop that I'm considering there. So I can consider loop B to D back to C and from C to B. That's a loop. That'll be our loop 2. It's a loop that you formed. So from this loop, are we having a voltage? Because we're supposed to have the sum of voltage drop, the sum of the supply voltage that we have is not this one. In this loop here that we have here on the supply, do we have the supply here? Do we have a voltage there that is given? We do not have. So it is 0, which is equal to the sum of the voltage drops. So we're going to move from B to D. Let's move on from B to D. What's happening? Are we moving in the same direction of the loop? Yes. So that's a positive. So that'll be 20 into the current, that's I1, minus I2. Okay? You move on from D to C. What is happening? From D to C. What is happening? You are opposing here. Look, this is where you're going, but the current is moving the other direction. So that will be a negative because we are opposing the way this current is moving. So that's a negative 50 times the current given there. What is the current? That's I3. Then we move on from C to B, this one. What is happening as we are moving this direction? And the current is opposing the movement. The current is going this side as we're going the other way. So that is going to be a negative. You're opposing. So that's a negative again. So you're going to obtain minus 40 times the current there, which is I2. That's why we formed an equation. Is to form an equation, it's not supposed to be, we are rounding off on this. No, it can be from anyway. So from a textbook, they used 30. So in this case, I'm not going to also make that 30. I want you to know that you can also use other ways. So let's have other ways that we can actually have so that we use that for revisions purposes. All right. So that's 0 is equal to expand the first bracket, 20 times I1 there, that's 20 I1, 20 I2. Okay, minus 50 I3 minus 40 I2. So that's it. We can collect the like terms. In this case, current 1 is just this one only. So that will be 20 I1. If you take here, there is minus 20 I2 minus 40 I2. That will be minus 60 I2. Then we are left with minus 50 I3. So it is just a simplification there. So you've got equation 2. Has you formed an equation? So from these equations, we're going to have, so you say this is our 1. Then our equation 2, we're going to take this as it is. So it was 20 I1 minus 60 I2 minus 50 I3, which is equal to 0. That's how you're going to use it. You have your equation. So the question is that, are we going to form another equation? Yes. Why is that so? Because of the unknown values that we have here. How many unknown values do we have? 1, 2, 3. Current 1, current 2, current 3. So you must have 3 equations to solve those currents because we've got 3 unknown. 2 unknown, you just work with your normal equations. You solve for those 2. You work with 2 equations. 3 unknown, 3 equations. So since that is the case, so let's form another equation because we need to have 3 equations in that case. So you can even choose this one from C to D to E back to C. It's a loop. It's a loop that you've taken. So considering our loop 3, which is from point C to D to E and back to C. It's up to you the way that you're going to take. Are you going to take it as C, E? The way that you take it's yours. As long you form equations that are from that loop, do not worry about that. Solve those equations. At the end, you'll find your answers will be the same. As long you are doing those as long you're forming equations properly, not making mistakes. So do not be limited when you're solving this type of equation. Form equations of your choice. All right. So let's see. In this loop, we do not have any voltage given supply one. So we're going to have 0 is equal to, then we consider the voltage drops. Current times resistance. So let's move from C to D. From C to D, we are moving in the same direction of our loop. The current is moving in the same direction. So that's a positive 50 times I3. Okay. You move on from D to E. What is happening from D to E? You're moving in the same direction. The current here is moving in the same direction as the loop. So that's a positive there. So that's 50 times the current in this loop, in this branch. What is the current flowing in this branch? That is I1 minus I2 plus I3. That's it. And we can move on from E to C, which is the last part, from E to C. What is happening from E to C? You are opposing. Look, the current is going this way. Us, you're going that way. So that's a negative. You're opposing. So that will be negative 40 into the given current. What is our current? I2 minus I3. So that's the case there. You are opposing. So you must subtract. Use a negative. You formed an equation. So you're not supposed to be limited, guys. All right, so let's solve. Let's simplify first. That's 50. I3 expand by 50. This bracket, as you can see, every part is going to be multiplied by 50. That's 50. I1, 50, and minus I2, that's minus 50. I2. I3 is going to be 50. I3. Everything has been multiplied by 50. This part by negative 40. Negative 40 times I2. That's negative 40 I2 times I3 there. That's a positive 40 I3. Then you can consider collecting of the like terms. Are we having any part of the like terms? Considering I1, we've got I1 here. That's the only I1 that we have. All right, let's move on to I2. There is I2 here, minus 50 I2. There is minus 40 I2 there. Then the remaining is I3. All right, so let us take it that way. So as you can see, we only have this part of I1. So that's 50 I1. The part of I2, minus 50, minus 40, which is going to give us minus 90 I2. Then the part of I3, that is the remaining ones that are that we are having there. We just have to add this 50 I3 plus 50 I3, this one, which is going to be 100, plus this 40, which is 140 I3. So that's it. So that's 140 I3. You have formed an equation. That's your equation 3. All right. So that is what you have there. So this is our equation as it is. I'm going to take it 50 I1 minus 90 I2 plus 140 I3 is equal to 0. You have an equation from there. So you form these equations, everything is indicated. You've got everything being given, indicated. Now, after forming these, you have three equations. You are now supposed to solve these equations. How to solve again is your choice. How to solve these equations here is your choice. Are you going to use elimination, substitution? Are you going to even use those determinants from your mathematics N4? Because as long as you are working with three unknown, you can even use any of your mathematical calculations. You can even use determinants. Remember, that's why we have determinants under N4. If you check, they also have circuits there. They want you to understand that you can even use those determinants in solving of these unknowns. So just also go through your determinants. So anyways, I'm just going to look for a suitable method that we can work with. Since we can see that in the first equation, we just have I2 and I3. We can take advantage of that. Use substitution method so that we substitute into equation 2 and into equation 3, whatever that you make the subject from equation 1. So using substitution method from the first part, you're gonna make, you make whatever that you want. You can make I3 the subject, it's up to you. You can make I2 the subject from equation 1, it's up to you. So in this case, I'm gonna make I2 the subject. Okay, that's from equation 1. From equation 1. All right, so from equation 1, I'm gonna take this as 80. I2 is equal to, remember, there was a minus 40 there, so I'm going to take it to the other hand. So it's going to be 30. If I take the minus 40 this side, it will be a positive. So that's positive 40 I3. Okay, so it's going to be like this, positive 40 I3. I've taken the minus 40 this side. It's from equation 1. Remember, I want to make I2 the subject, so simply I'm just going to divide by 80 like this. That's I2 is equal to, if I divide this, I'm gonna get 0.375. Okay, plus if I divide 40 and 80, that's 0.5. So we've got 0.5 I3. All right, so we have formed another equation from that. So I'm just gonna call this equation 4. All right, so this will be our equation 4. So we have made I2 the subject from equation 1. So like I said, you're making this so that you substitute into these two remaining I2 and equation 2 and equation 3. So you're going to substitute in this case. Substitute I2 from equation 5. Or let's just say equation 4, that equation 4. Okay, I2, which is simply equation 4 into what? Equation 2 and 3. Remember, you made the subject from equation 1. You made the subject from equation 1. So you substitute into these ones that are remaining now. So you're going to substitute into equation 2 and equation 3. All right, let's see what's going to happen if you do that. Remember, I2 is given. This is our I2 here. So you're going to substitute this. Let's start on this equation 2. So from equation 2, it is given as 20 I1 minus 60 I2. So that's minus 60 into I2. What is your I2? This is your I2. You're now substituting this. So that's 0.375 plus 0.5 I3. We have substituted I2. In place of I2, you substituted with I2 from our equation 4. Remember, that was our equation 4 here. So we have got minus 50 I3 there. So we've got minus 50 I3, which is equal to 0. Thus, we have formed an equation. Let's see what's going to happen. What are we remaining with? Let's simplify first. So simplifying this, you are going to obtain 20 I1 expand by 60. negative 60, this bracket, negative 60 times this 0, comma, it's going to be negative 22,5. That's negative 22,5. Negative 60 times 0, 0,5. That's negative 30i3. Okay, already there is a minus 50 i3 here, which is equal to 0. So if you are to take a closer look, you'll see that you are left with two unknown values this time. I1, I2, I1 and I3. These are the only unknown values that we have, I1 and I3. So it's going to be easier for us to work this. All right, so let's simplify 20i1. Let's collect the part of I3 together. That's minus 30. I3 here. And this minus 50 I3. These are like terms. So you can actually consider these like terms. That will be negative 80. So you're going to have negative 80 I3. You can even take the minus 22,5 to the other side of the equation. That will be a positive there. Minus 20. Remember, guys, when you're dealing with two unknown, x plus y is equal to 3. 2x plus 2y is equal to 7. Then it's just two unknown values. That is what is happening. We write the numbers on the other hand. So this is it. You have I1 and I3. So you can take the minus 22,5 the other side. So it's going to be 22,5. Thus, we formed another equation by substituting into equation 2. Remember, I started with equation 2. We have formed another equation. So you're going to call this equation 5. Remember, we have equation 4 there. So you're going to call this equation 5. Remember, I said you are supposed to substitute I2, which is our equation 4, into equation 2 and equation 3. So we are supposed to do this also in equation 3. Okay? So substitute this now in equation 3. From equation 3, this is what we had. It was 50i1. This was our equation 3. We are substituting the same I2, this one, which is our equation 4. The statement is still the same here. We're supposed to substitute this in both. We'll see what's going to happen there. So it will be 50i1 minus 90i2. In place of i2, you're substituting this i2 that you got there, which is 0,375 plus 0,5 I3, like this. All right, then we are remaining with the plus 140 I3 there. So it's going to be plus 140 I3. Okay, so that will be plus 140. All right, that's 140 I3, which is equal to 0. Let's just hope this is going to allow us to finish, guys. All right, so this is what we have. Simplifying this, we're going to obtain 50i1, that's we have to distribute by negative 90 the bracket. So negative 90 times 0, comma this 3, it was going to be negative 33.75. Negative 90 times this positive 0, 0,5, it was going to be negative 45 I3 plus 140 I3 is equal to 0. So from this stage, you can notice that we have got the same situation like what we had here, where we had to collect the like terms. So we've got the 50 I1, then considering I3, there is I3 there, there is also I3. So that's minus 45 plus 140. On your calculator, what are you going to have? 140 minus 45, that is going to be 95. So you're going to obtain 95 I3, which is equal to, you can transpose this now to the other side of the equation. It was a negative. On the other side, it will be a positive. So that's 33.75. We have formed an equation again, which you can call this equation 6. This is done by substituting equation 4 into equation 3, which is the same thing that we did here by substituting that same equation 4, which is our I2, this one, into equation 2 and 3. The remaining equations that you had, remember these were the remaining equations here when you made the subject from I1. you substitute in equation 2 and 3. After substituting into equation 3 and 2, or 2 and 3, you are going to notice that the remaining equations can now be solved in a better or any other way that you are used. Then now you can, guys, look equation 5 and 6. There are two unknown values. These are the normal equations that we are used to. So to solve equation 5 and 6 so that you have I1 and I3, you use any suitable way. Any suitable way of your choice, guys. So now we need to solve equation 5 and 6, these ones, equation 5 and 6. Okay, solve for I1, solve for I1 and I3 in equation 5 and 6. So we're going to consider equation 5 and 6. Equation 5 and 6, we had 20 I1 minus 80 I3, which is equal to 22,5. Then this was 50 I1 plus 95 I3, okay, which is equal to 33.75. This is what we have. So this is what we had from our equation, what? Equation 5 and 6. So like I said, how do you solve here, guys? It's up to you. This, you can even use again substitution. You can make I1 the subject, then you substitute whatever way that you want. You can use elimination method. The way that you solve there, it's in your hands. So in this case, I'm just going to talk of the elimination method. Let's eliminate I1. Okay. Let's try to eliminate I1. So to eliminate I1, just going to interchange. Remember, you just have to multiply on top. Like, just interchange this. So I'm just going to multiply by 50 on top, by 20 here. In actual sense, you're just supposed to multiply by 2. Yeah, you can even reduce this, multiply by 2. Then you multiply by what? Then you multiply by 5 on top. So that's the idea, that you can reduce these numbers. So I talked about that on working with whenever you're working with the elimination method. If you still remember, you can reduce this. So that's in your hands. You can use the 50. It's up to you. I'm not saying it's wrong. It's in your hands. You can reduce that. All right. Anyways, let's multiply 5 times 100. 5 times this 20. It's going to be 100. So you're multiplying, remember, the whole part here, elimination method. 5 times 8, you're multiplying each and every part that you are given. So 5 times 80, that was going to be minus 400. So we've got minus 400 I3, which is equal to 5 times, then we're going to multiply 5 and 22. That's 22,5. Okay, that was going to give us 112,5. Okay. You do the same thing by 2 here. That was going to be 100 I1. You're multiplying each and everything of this equation. 6 by what? By 2. So that's 100. 2 times 95, which was going to give us positive 190 by 3, which is equal to 2 times this value, which was going to be 67,5. Okay, that was going to be 67,5. As you can see, I1 and I1 are the same. So you can simply eliminate that I1. So how are you going to eliminate? Are you going to add or you're going to subtract? So in this case, we can subtract in order for us to eliminate this part of what? Of I1. That means we have eliminated I1. 100 minus 100, that's a 0 there. So we have eliminated I1. So you're going to do the same thing, minus 400 minus 190. So you have to find the difference there of minus 400 minus plus 90. So it's like this, minus 400 minus plus 190. So as you can see, the plus there does not even have any effect that is gonna have. So it's gonna be a minus. This it's gonna be a minus. So that's minus in that case. Okay, that's gonna be, sorry for that. So it's gonna be minus 590. So that's minus 590 I3, which is equal to, do the same thing, this minus this. So you're gonna subtract 112.5 minus 67.5. That was gonna give us something like okay, 45. That was gonna give us a 45 there. Okay, so make sure that you subtract properly. In this case, you must be careful also on your calculator, the way that you're gonna simplify. So that was a 45 there, and we can divide by this number so that you obtain the value of I3. There's a minus 490 there. So if we divide by negative 590, both sides negative 590, that was gonna give us the value of I3. So I3 was going to give us, if you check on your calculator, the first thing that you get after dividing is negative 9 over 118. Okay, which you can write it as a decimal to 3 decimal places is going to be negative 0.076. Okay, that's our current. So the negative there is just because of the direction or being opposite to the way that must be taken. So you can leave it like that for the sake of other currents to be determined. But when you are doing other calculations, like you're calculating the voltage, the power, you just take this current, know that it's a positive. But as you are to calculate other currents, you use it as a negative like that. So since you have to calculate other currents, you're going to leave it like that as a negative. But what I was trying to say here is that for you also to have exact values, yes, you can substitute this one. But remember, it depends when it's an exam, the way that you have solved, a way that the other one is solved, and the way that another person is solved might differ. So for you to just maintain exact answers or exact values, use the fraction in the substitutions so that you can obtain exact answers. Okay, you have I1. Remember, guys, your elimination, you have calculated, I3. You can even use any one of these equations, still from equation 5 and 6. We can use any one of these two equations to find I1. Okay, so let's take from equation 5. From equation 5, we are given that 20 I1 minus 80 I3. Okay, sorry, that's minus 80. I3 is equal to 22.5. We have I3, we have calculated this. From equation 5, we can substitute. You can even substitute in equation 6, it's your choice. So that's 20 I1 minus 80 times I3, which is the one that we got here. But like I said, for the proper values, for exact values, because the way that we are calculating is different, try to just use a fraction so that at least your answers, they will be exact. If you are using a fraction, those are the exact answers that are supposed to be actually have been obtained. So you do not worry when you're using a fraction. And like I said, when you're calculating any other current, you use it as a negative. You use it as a negative like that. Okay, so let's find I1. You can take this to the other side. It becomes a positive. You can simplify this. Now it's in your hands. Or you can even just transpose to the other side. That will be 22.5 plus 80 into minus 9 over 118. Remember, it was a negative. So once you take it, it will be a positive. So that's positive 80. Since we want to find I1, simply divide by 20. Simply divide by 20 both sides. So that means I1 is going to be the whole of this part, then divided by what? Divided by 20. And that was going to give us 0.820 amps. Okay, that is representing what? Representing I1. And as a fraction before, you got this one as a decimal. On your calculator, it was going to give you something like, it was going to give you like 387, 387 over 472. Okay, so meaning to say that whenever you are to substitute it like that in case that I1 is there. So we have I1, we have I3, now we are left with I2. So which equation is best for us to use to calculate I2? We can't use these two equations here because we do not have I2 here. There's only I1 and I3. So we must trace back where we have I2. If we trace back in these equations, it's true that here it's 5 and 6. 5 and 6, we don't have I2. In these equations here, in equation 2 and in equation 3, there is I2, which is fine. But if you take a closer look, equation 4 will be of advantage because already I2 is the subject here, written in terms of I3. So we can take advantage of equation 4, substitute in equation 4 to find what? To find I2. All right, so to find I2, in this case, you're going to need I2. Find I2. So to find I2 from equation 4, we saw that from equation 4, I2 is equal to 0.375 plus 0.5 I3. This is what you were given before. All right, it was plus I3. So you can substitute. That's equation, that's I2 is going to be 0.375 plus 0.5 times I3. Remember, our I3 was negative this. But like I said, for us to have exact values, let's just try to use the fraction as it is negative 9 over 118, or that decimal, this one that you are seeing here. Just use it like that, no problem. So that is going to give us 0.337 amps. Okay, so that's our current 2. So you have determined current 1, current 2, current 3. But the question, remember, it was to calculate the current in each branch. In each branch. So let's go back now and fill in the other remaining ones. So guys, remember those currents, and I'm going to erase 1 or 2 things here because you've got a lot of things to consider here. All right. So we have I1, we have I2, I3, and so on. So let us consider now the currents in the other branches. So like I said, guys, I'm just going to erase here because we now have a lot of things. And I did not even hope it's going to be like this too long, guys. Anyways, it's fine. Let's see. So the currents in other branches. So for other branches, because that was our question, remember here. Question is asking you to calculate the current in each branch using what? Kirchhoff's. Also the voltage later on, but we need the current in each branch. So in this case, other branches, we're going to consider which branches are we talking about. Because I1 we have, I2 we have, I3 we have. So we're going to consider the branch of BD, which is for the branch of BD where we have I1 minus I2. It was just going to subtract the values that we got there, guys. Because of this, there's now a lot of things. I'm just going to take those values. I just want you to recall those currents. Remember, I1 we got 0.20, so that's 0.2. 0.820, which is 0.82, minus I2, which we got 0.337. Remember, we have got these values. So that was going to give us 0.483. So that is in the branch of BD, in this branch here. We also have this branch here of DE. So we also have the branch of DE. In this branch of DE, that's where we have I1 minus I2 plus I3. So it was going to be I1. Remember, I1 it was 0.82 minus I2. Remember our I2 0.337 plus I3. I3 we got it as 0. It was a negative. That was that negative. Now we can use those decimals. There's no need for us to maintain those fractions. Now we can just use those decimals. Negative 0.076. That was going to give us 0.407 amps. Then we also have this branch, the branch of CE, this one. Those branches that we stated before, guys. Okay, so we also have the branch of CE. And in this branch of CE, the current is given as I2 minus I1. So the current there is given as I2 minus I3, sorry. Remember, I2, you have the value 0.337. You subtract I3. I3, it was a negative 0.076. So that was going to give us the current in the branch of CE. These are the currents now in each and every branch that is remaining. So that was going to give us 0.413 amps. Just like that. So we've got each and every current in this circuit. Okay, then after, they also need you to, using also the Kirchhoff's laws, also determine the voltage and current across R5. All right. So the current across R5, guys, this is I3, so already calculated this one. The current across R5 is our I3. This is I3 that we calculated before. So this one is already there. So the question was actually supposed to be voltage and power there, because we had calculated like all these currents. So here, I think maybe they wanted you to say power there. And the power through R5. So it was supposed to be power, not the current, because already the current we calculated on this one. Guys, remember the first question was calculate the current in each branch. So it's already there. So in terms of the voltage across this R5, let us see here. We're just going to need voltage. Remember voltage, that is what? Current times resistance. So that's it, guys. We have done there. So in this case, to calculate the voltage across this resistor R5, it was going to be current I3 flowing there. This is the current that is flowing times R5. So I3, remember, it was a negative. We got this as a negative. But when you are doing calculations, you use it as a positive. Calculating voltage power, you use as a positive value. Currents are the ones that are affected with that negative when you are calculating, because the direction is important in those currents. But here we just need the voltage drop here. Okay, so ignore that negative. That's 0.076 times the resistance. That is 50 ohms, or R5 there, which is what? 50 ohms. So that was going to give us the voltage across R5, which is going to give us 3.8 volts. So if it is to calculate the power, they can also ask you to calculate the power. Power, you can use voltage and resistance, V squared over R. If there is a voltage now, power, you can use I squared R. If you have only current and resistance, whatever that you can give, you are given voltage and current, because now the voltage is there, the current is there. So you can calculate power in any other way if you are being asked to calculate that power. So these are the typical questions that you might be given on a bridge network. You need to formulate and you need to formulate your currents. That's the first thing. Currents across the branch that you are given. In case that you are given these currents, there is no need of us wasting much time because already they are given the currents. But in this question that we had, guys, we had nothing on this part. It was just like this. Okay. So now I erase like everything now. Okay. It was just like this. There is nothing that you had. So you must figure out determining of those unknown currents first in terms of what? They must be written in terms of the given currents, in terms of I1, I2, or I3. Any, or as long it can be written in terms of these currents, you are done. You are not going to introduce another one and say, this is now I4, this is now I5, this is now I6. No. You work with these three currents, I1, I2, I3, form equations using those ones. So this is how you can simply answer this type of a question. So I just want us to work with more questions as we are doing our revisions. Let's try to do as many questions as we can, and check also typical exam questions. How do they ask these questions so that you get used to these questions till we meet again.